Good morning. Oh,
Morning, Drew.
we'll
Morning,
get
Drew.
making sure my speaker worked.
Yep, it's working.
Good. I'm playing speaker roulette. Every time I join with a different conferencing tool, who knows what speaker I'm with.
Yeah, so the teams messes up the Zoom and the Zoom messes up the WebEx and it goes
Hmm.
on and on.
Oh, and throw Google Meet in there too. But yeah.
Oh, I haven't, you know what? I haven't used Google Meet yet. Whatever happened to Citrix? Remember, they used to be fairly common.
I don't know.
There were more. Hey, good morning, folks. Charlie, weren't there
Well,
more in like desktop sharing and stuff? Citrix work, remote
uh-huh.
work setup.
Okay, yeah, because I remember there used to be a lot of meetings I would join with Citrix, but then it just seemed to go away.
So, Drew, I think a couple of things we need to do today. One, we need to maybe flash what we're planning for Global Summit or with the team, get their feedback. I don't know. Did we? I think that should be okay. And then I don't know if you talked about the hardware management presentation. I think I can send that out too, or if you want to talk about it.
Yeah. And then the other thing we've been doing is we started going through the memory scenarios. The
Yeah,
memory.
yeah, I was coming to that. But before that, one more thing. Drew, how do you, I want to ask this group, how do we feel about maybe swapping the meeting time with the RAS API? Will that be something that you think is a okay idea? Or something that we can play with, just what us out a little bit, see how people feel
Well, when
about it.
do you mean when you say swapping, do you mean literally swapping?
Meaning we hold this meeting when we hold the RAS API meeting, and we hold this meeting when we hold. I mean the other way, Yeah, change the.
Oh, okay. Because I was thinking you meant um, like when our off weeks use the slot for RAS API. But yeah, we
I
can.
mean, I think RAS API still wants to meet weekly. Isn't that right?
That's true.
So then that would be generally not a very good idea to do one meeting one day, another meeting another day. I just think that people tend to forget. That's my, or at least I do. Right.
Well, I thought we had this meeting so that it was easier for the memory vendors and with folks in Asia to join.
Yeah. Yeah. So other alternative would be to hold this meeting in the evening, like 5 p.m. Pacific. That is also a time that works for, folks in Asia. I mean, these are just brainstorming, right? I'm just trying to. I'm just trying to see if so that something works for attendees here.
The problem is, it looks like we don't quite have quorum, do we? Well, it's building. We're getting more people.
Right. And I see we have, I think, a new attendee, Meenakshi. I don't know if you're first time here or I was not there when you attended previously.
Yeah, I am first time here. My name is Meenakshi, but I usually go by Meena, and I'm from Meta. Anil Agarwal, we are co-workers. So I joined this meeting specifically because I'm implementing DIM manufacturing date field to be retained as a part of DIM inventory and it should be part of the OCP spec so that vendors know to pull that out also for DDR4 and DDR5. My motivation is to figure out what this meeting is about. Anil invited me to join it. And thank you.
Welcome.
Go ahead, Drew.
I was just saying welcome. Glad you're here.
Yeah.
Thank
I
you.
think we should discuss that. I think I saw a comment by Anil, but we should ask the folks like Ivan here and Roy and folks from Samsung. But I think we infer the manufacturing date from the other numbers that we capture.
I was looking at a draft that Anil had for OCP and for DIM, and it didn't include the DIM manufacturing date. But
No,
we
not
should
directly. That's what I'm saying. Not directly, because
not
we have
directly.
manufacturing serial number. And Ivan, you want to add? My knowledge may be sketchy in this area.
Yeah, hi Mina. I think that I wouldn't have a problem with directly including it. Like Yogesh mentioned, that the reason we didn't is because we can pull it out of the serial number, or use the serial number to look that up. So that's the reason it's not explicitly
Right,
included in the current version of the spec. But
right.
I
So
wouldn't mind adding it for future revs.
it would be great if you could add it, because pulling it out of the serial number assumes that we are storing the full 98, 19, or 18 character serial number, and then we are parsing it out of it.
Right.
Yes. So getting it directly from the SPD, serial presence detect, to me, is a more grounded way of getting it. So yeah, that would be great if we can include
Yeah,
that.
I think part of thinking is, if you are in that realm of debug where you need to go back to when was this DIM manufactured, is it just the aging concern, or it's just like what happened in the manufacturing in that batch concern? Because if that's where we are,
Yeah, that's
then
the
we're
latter.
probably
The
the
latter is
aging,
more. No,
the age.
the latter is more of a concern. Usually, we need
Right. So
granularity.
then you're already using what we call the DIM vendor analyzer, which will easily parse the information out. That was kind of thought process here.
Yeah.
Okay.
And I think there's been some, we could, and when I talked to Neil, there have been some, like Neil and I have been working through this, but there have been challenges, and I think we're on the same page now. But our intent is that, just in general, that we gather fairly rich error logs, but we don't. But when we have this public-facing group, we say we don't care if they're proprietary and have a lot of like data that works for the vendor. And the reason being is, like a particular GPU vendor might want to encrypt their logs. One CPU vendor might have a different register set than a different CPU vendor for logging memory errors. And so when we talk about what goes in the error log, we're talking in this meeting conceptually, that conceptually this data is contained in the error log, but we're not specifying the format. And then what happens is those error logs get passed to a tool provided by the CPU manufacturer and that incorporates something from the memory manufacturer. That tool can massage the data, decode the data, and extract from it the things that we're interested in. And so the decoder, we like as a hyperscaler, I'm from Microsoft, and Neil and I both are aligned that we want to see the details, and we as trusted partners will have things like NDAs that allow us to see register contents and what registers mean with our partners, where a third party that's not part of this effort, the gas station down the street, might not have any relationship with any of us. They may just buy the product, but they can still get this error log, and maybe they don't get the decoded value from the tool, but they still get the analyzer, and the analyzer tells them what to do. And so our goal here is to make something that works universally for everyone, but that also as a hyperscaler can be um, uh, provided to us with the ability to see the details that we want. And so the question we'll have to investigate, and I think this is really for the next version of the spec, is it acceptable to be able to pull this out of the decoded data from with the help of the CPU and DIMM vendors, or is it something we actually need to embed in the log? And either way is okay. We don't know yet. We just finished a rev of the spec, but I wanted you to understand the philosophy that the data that we were trying to build a universal pipeline that sends data, and when we get that data, then we can decode it and look into it and see what we want to see and do what we need to do with it. But the plumbing, including the origination of the data, can be in whatever format works for the people creating the silicon. So do you follow what I'm saying?
Yes. Thank you, Drew, for the explanation. That makes a lot of sense. Yes, and probably this will take some time to iterate, and maybe it's for the next version, but it's good to keep in mind
Yeah,
how you
yeah,
build.
absolutely. And I mean, the reason we're saying it's not in this version is that we just had this version approved, so it's getting published. We just finished a revision, but we're at the point where our plan is, we've been going through a few memory scenarios to get everyone. The other thing that we do in this group is we're trying to get everyone on the same page about how things work. And one of the problems the memory vendors have is that they get sent a lot of DIMMs that aren't broken. Someone sees a corrected error in a DIMM and goes, "Oh, the DIMM's bad. Here, vendor, take it back." And maybe it was a soft error. And so that's another thing I want to walk through with some scenarios to create a document that provides a common understanding for memory errors. And so we'll go through that scenario, and then we'll go through the next version of the spec. So anyway, we're very open to this discussion. We'll just have to see how it plays out. Yogesh, I was going to suggest, why don't I flash the slides we created, if that's okay, for the hardware the hardware management team.
Yeah.
Get approval of our doc.
Yeah, that, and also, sorry team, I said I'll share with the team, but we just got it ready yesterday. So the slides that we're planning for Global Summit also, Drew, we
Oh
can share
yeah.
those.
If you've got those handy, why don't you get those ready, and I'll show this briefly. So
Yeah.
so I have wonderful news, folks. We have a fairly complicated process for making a contribution to OCP. At least feels complicated to me, but we've gone through the process, and one step of the process is that you present the contribution to your project sponsorship. And so that happened on the 25th, and we went over our doc, the version 1.5 of the doc. I'm sorry, version 1.0 of the doc, and we went over the infrastructure requirements and a data poisoning paper I wrote. And it was really FMFM, which was scheduled, but they let us schedule the other two. And we can share. In fact, I'll paste this link in the chat for this meeting, and y'all are welcome to look at the slides. It's a little late to provide comment because Yogesh and I had to crank them out and get them presented. But what we were showing is, in the overall fault management infrastructure, we did in-band logging, for Meta, in the overall architecture and the hardware fault management team. And then for memory, we did, logging and analysis. And we show the companies that are involved. And so we went over, the hardware fault management framework paper. And I'm going to just blast through it because we don't need to go through the details. You'll see these things called, contribution and OCP tenants. We have to explain our tenants and how we, fit OCP's, guiding principles. So we do that for all the papers. Here's the fleet memory one. And, we focused on DDR5. We have different sets of data. We're trying to standardize that and propose a framework for analyzing it. And we want it to be broadly applicable. And that's something I want to emphasize over and over again. I'm a hyperscaler. I want good tools for hyperscalers, but we want to make this universally usable for anyone that has a thing that can detect a memory error, so that y'all invest in it, right? The more broadly usable it is, the more you're likely to invest in it because it helps more of your customers. I went over the contents of the doc and just kind of a picture to show how we fit things together. Went over the tenets, and then the last thing we did is a paper that I wrote that talks about how poison works. And what happened is that every single place I've worked, from HP to Google to Microsoft, I've ended up needing to write a document that kind of teaches, especially OS people, how hardware data poisoning works. And it just, a lot of times they'll do things like they'll see poison generated and blame memory. And it may not be memory's fault. It could have easily been a PCI device that DMA'd, a poison TLP that put poison in memory. And so, memory is innocent, or maybe memory's not. And so, how do you tell? And so, this is kind of a baseline doc. Yeah, Sean, thanks. The doc I wrote at Google call is "Go What Is Poison." So if you ever look at it, I think it may still be there. But
it's still there.
Okay, cool. That warms my heart to hear it's still usable. But I wrote this because we just need to we need to make this pretty widely understood. I've heard things even recently from I/O device providers that say, "Oh, we don't have to handle poison correctly in an I/O device. People rarely use it." And for a data center, especially for an AI workload where you have 100,000 GPUs, the last thing you want is something corrupting your training data and creating a bad model, especially if you spent months training it. So poison is very important, and so that's and it relates to this group because I'm trying to make sure that people don't blame memory inappropriately. And so as we release the more documents about how analysis works, I'll probably update the poison document to say, hey folks, if you really want to do a good job analyzing memory errors, use the FMFM analyzers. And it will tell you if memory was the culprit or not. So that's it. And then we had a few backup slides. But in summary, the good news is our contributions are approved. I think there's a last steering committee check that happens, but they rarely give feedback. The main people that look at give us scrutiny have looked at it and are okay. They believe it falls under the charter of hardware management. So I expect them to show up on the portal with no additional work from us. And you guess you had the date. It's in September? Or is that?
Yes, I was going to mention that, right? So I think you might have seen the email I sent about, please check your name is correct, and if you need any further reviews from your company, get it done before September 5th is what I said in my email. That's a Friday. Yeah. So we want to give folks some time so they can make sure they're acknowledged appropriately, and also they are meeting their company's guidelines for contributing here.
And we'll send out links on the contribution portal to find these once they're out. But anyway, congratulations, we did it. We got the paper out. So I'm thrilled that we made this progress. Okay, Yogesh, did you want to share the other presentation?
Sure. Let me do that.
Yeah, that's great news, Drew. And Yogesh, I was excited to see those emails yesterday.
Yeah,
Great to
congratulations.
get it in before the summit.
Yeah, and I think now we're getting more and more traction. So and at Microsoft we're doing a proof of concept to demonstrate RAS API concepts. And so we're going to analyze memory errors. And I think our initial plan is to do we're going to have a dummy CPR initially, then we're going to do memory errors, and ultimately we want to show that we can do runtime post-package repair. But we're going to fake out the RAS API behavior because it's obviously not, ready yet. So, but we're going to demonstrate, we're going to just prove the concept works. And what we maybe want to do is collaborate with some of you as we build the proof of concept to take your memory analyzers. Like we got to crawl. We've got to do one basic thing, get the message going, from the host to the analysis framework, and then from the analysis framework back to the host. But once we get the initial paths plumbed, we can begin iterating on more and more of what we've done here to build everything out. So, I think we want to talk to y'all about using your analyzers in this process as well.
Cool. Thank you, Drew. So you guys can see what I'm sharing?
Yes, we see it. Thanks.
Okay, so yeah, this is the draft that we submitted for OCP Global Summit. Like I said, although hardware management got a full day track, they had, again, too many. I don't remember the numbers.
55.
Suffices to too many for all of us to have a dedicated track. So joint track, 30 minutes. My original idea was to have a panel discussion on RAS API. I wanted to have more folks involved in that from Google, Sean, or from ARM and other places, but Meta, but could not happen. So this is what we kind of got agreed to, approved, that hey, we'll split this like this. I'll start with the update, and then we'll give, because we originally had 3 presenters for RAS API, and it's hard to say no to people. We have 12 minutes for RAS API. Will be a lot of updates there too. So that, and then for FMFM, part of the update I'll cover as part of my initial 4 minutes. So what is the group about? But Drew will talk about the requirements in 5 minutes. And then we move on to, hardware fault management. And then again, Drew will wrap up, and we'll have hopefully some time for questions. So yeah, this is where we are. This will be the initial 4 minutes update stuff. So these are still draft. I really haven't spent too much time on these. This is what I have though for, actually, Drew, this is your slide. I kind of moved it to the first, or maybe it's not yours. Maybe I modeled it after your RAS API slide. So basically to talk about what the Workstream does, what does it enable folks to do, and you can see some of the verbiage from your last year's slide. I liked it a lot. So it enables everyone, DRAM and vendors to take advantage of the fleet data to solve memory error handling problems and drive innovations. This is achieved by contributing the requirements, which we just did. Drew talked about it, standardizing the formats and interfaces, which is kind of happening in RAS API. But we're also defining what memory needs to capture in the requirements. And, the abstraction, again, is vendor agnostic part of RAS API, which we comply with, right? And then talk about the meeting cadence, who are the participants, what's the current focus, what is the contributed version, and I'll include link to the contribution here. Any comments, or am I missing anything? Anything on that one slider? Okay, then again, Drew, this will be what you'll be presenting. I think so. This is, I think, directly lifted from the contribution slide that she presented.
Oh, that's funny. Okay. I like it. That works.
I mean, we just worked on it, so there's no need to reinvent the wheel.
Yeah, conservation of effort. Good.
Yeah, but we can take more feedback for Global Summit from this group, because they're the ones who work with us all along. So,
absolutely.
Yeah, I'm just going to let you guys read it. Okay, moving on to the next slide. Stop me if you have any thoughts or want to have more time. This is the same slide, content and the high-level overview diagram. And that's pretty much it, actually. Then we jump right to the wrap-up slide where Drew, you'll talk about, the project wikis are here, subscription emailing lists are subscription emails for mailing lists are here, and, get involved. Unfortunately, it cannot be more detailed than this, given we have total of maybe 5 minutes for FMFM. Okay.
Sounds good. Okay.
All right, then.
So do we want to shift to the scenario now?
Yeah, please do.
Okay. So we're taking a little bit of a break from the spec to work on scenarios. And if you remember, oh, and I can't start a share while you're sharing, so.
I am trying to figure out how to stop sharing. I think I lost it.
Okay, I'll give you a
somewhere.
sec. But anyway, so one of the things that we were doing in our documents was going through scenarios. And if you remember, we decided to pull those out so that we didn't hold the documents up, and then we can walk through scenarios separately. And so we pulled some of the memory stuff out, and I wrote a memory scenario. And I'll just remind folks, the intent was to show how polling and rate limiting and how memory errors, we could have a memory error, and if we've stored all zeros to something stuck at 0, we won't see it. Just pure and simple. It looks right. But when software starts using it and writes something to it, we could suddenly see a burst of errors, and nothing changed. And
sorry,
I got it.
I figured it out. You can share.
Yeah, I got it. And so and then the other thing that might happen is software may not access the memory, but the memory may be bad. So only the patrol scrubber sees the bits that are written incorrect values. And so what I wanted to show is I can have a failure, and as software progressively uses that memory more, the failure becomes more and more visible. And so that's one of the things I wanted to show, is that we're along for the ride. And the other thing I wanted to show was the futility of counting memory errors, and that we really want to use patterns, and we want to analyze, where the bits are flipped, and infer the failure mode, and use that inferred failure mode to evaluate how the error impacts the CPU's ECC. In other words, I'm pointing people to the analyzers we're developing here. So anyway, hopefully that makes sense. And so we went over this overview before, and so then we've had some reviews. And so what I thought I'd do today is we'll start walking through the comments in the doc, and I'll paste the doc link for people to review the scenario. Okay, and I also pasted the poison doc just because I thought folks might be interested in it. So feel free to click on it, and if you don't have access, I'll give you access. Okay, so I'm I'll work on referencing the FMFM doc. I'm sorry, I've been so busy with other things I haven't gotten to this. But I'm also showing the difference of software-driven polling, software rate limiting. Oh, I guess that's kind of being fleshed out here, and hardware rate limiting, and leaky bucket, which I really don't like. Let's see what you said here, Mita. Oh yeah. Okay, I think I did add software and hardware based
Yeah,
on.
I think that can be probably resolved now. You added those last time.
Okay, and then, well, then there's this last comment. Let's see. Yeah, I mean that's for sure that you can revert to polling. So
That's
uh,
pretty much what I
put
then
in, yeah,
put
yeah,
in
I agree.
the
Yeah,
suggestion.
yeah, I like what you suggested. Okay, I resolved it, and I'm going to accept this. Okay, thank you. Do we have Amer here today? Okay, I'll discuss this with him when he's here. Um, and I will also, yeah, the future reference. Um, I'll mention the overwrite rules because that's, I think I have another document I've written that describes that. So, you know, I'll see if I can put it somewhere. You know, the importance of overwrite rules. And so some of these things like the poison doc or a description of overwrite rules and how to handle them are just kind of education for folks. that you know, it's lessons learned, pain that we've discovered. So let's look at the description of the scenario. Um, I don't remember why I said partial row failure. I was thinking maybe it's a subword line rather than a main word line.
Okay, yeah, it's an old comment also. I also don't really know.
No, I mean, I think that's the only reason I said partial is that, you know, subword line may not affect all the row addresses, right? Um,
Yeah,
I
you
don't,
can resolve it. That's
okay.
fine.
Okay. Uh, let's see. Oh gosh, thank you for deleting that. Okay, good. I like your correction. Thank you. Okay, and so the assumption, I made some assumptions I just stated up front. You know, we have a partial row failure. It's a DRAM, and the DRAMs implement DDR5 features. So we have internal ECC corrections, and we have error check and scrub. And that the memory controller has basically, you know, chip kill kinds of things. I didn't mention bounded fault, even though bounded fault is wonderful and is like one of the best things the memory vendors have ever done for error handling. So thank you, memory vendors, for bounded fault. I'm not uh, uh, trying to ignore it. It's just easier to explain, you know, a simple thing for people that don't understand memory without it. Okay, and the memory controller implements scrubbing. So we have demand and control scrub, I'm assuming, and you know the system is deployed, so we're not running diagnostics. We're running user workloads and we're monitoring it. And so our analysis goals are to um, infer faults from error logs. You know, so that's always the key thing, and determine the best way to handle the faults. And so I'll accept this. Effective correctable memory error analysis rules. That's good. We want to filter out soft errors. So because there's no fix for a radiation strike. There's no repair. The part didn't break. And then we also want to infer the scope of failures by looking at patterns. And so those are, I think, my goals in analysis. And I guess the other thing is, you know, um, I'll say identify um, any actions that might help mitigate okay this is a memory scenario, so the memory analysis is really, you know, mitigating memory failures. Okay, and so then I address some misconceptions. The first one is the ability to diagnose memory faults from a single corrected error. You just can't do it. And so we need to look at errors over time and look for patterns. And people go, well, I can just count memory errors. And I remember one time talking to someone that was worried about row hammer, and their response was, "Oh, I'll just count memory errors, and if I see a high count, I'll just assume I'm being row hammered." And I'm like, no, that's not going to work. So, people look at statistics and counts of errors, and it's tragically bad because, and so this scenario will go through that. Why counting memory errors is a terrible idea. The other misconception I want to go through, and I don't see Roy here today, but is the need to capture every error. And Roy had something he presented in this group about, that we can do representative samples, and that's been my experience. The only way you capture every single memory error is with a logic analyzer. Software is unable to keep up with the rate at which memory controllers can generate errors, especially if it's a widespread error and the error logging software is running in the memory that has the corrected error. You just get too many of them. You cannot keep up. So I want to discuss the need for a representative sample. Okay, and so though I walk through the scenario, and I assume that we have this failure at the beginning of time, at the beginning of the scenario, and but the software, and if it's okay with folks, I'll just walk through and just jump in if you have questions or points you want to make. But my assumption is that part of a row in memory fails, but the memory isn't being used by software. And we'll assume that the memory was zeroed, because OSs will do that. They'll clear the memory out for security reasons so that when they hand it to the next user, the memory doesn't have anything in it. So let's just assume memory is empty and that the ECC is calculated and calculated for all zeros. And we'll assume that we can correct all the errors from a single DRAM for this DIM and ECC config, so we have basically chip fill. The ECC will see all zeros as corrected data. And now we assume the partial row failure is to be stuck at all zeros. So that's the fault. And now we assume that multiple cache line addresses are affected by this failure. And that's pretty easy to assume, because if you have a partial row, you will, in fact, I probably should just say, I'll say such a failure. It's really not an assumption. Such a failure will affect multiple cache lines addresses. I mean, that's just what happens. That's the way it works. Okay. So then the patrol scrubber, so now we're just sitting there, and the memory's not being used, and it's failed. Patrol scrubber scrubs the address, but the ECC is correct, so no errors logged. So we have a failure in memory, and we have no visibility to it. Now let's assume the OS starts using that memory. It allocates it to software, and software writes a single 1 to the failed row somewhere. Just sets a flag or something. Now we have a single bit error in a single cache line address. This is corrected inside the DDR5 DRAM, and it's captured in the ECS mode registers. So neither patrol scrubbing or demand read see the error. So we don't see it unless we're paying attention to the ECS errors. Now, and so I'm I just mentioned that. So unless we are logging and analyzing ECS data, this is visible to us. Okay. And then, and the beauty of the FMFM spec is it does include the ECS data. Okay, so next, let's say the software writes a 1 to a second bit in the same cache line. The same.
Drew, I have a question on the ECS data. My understanding is that we only get information from ECS if the number of errors is above a certain threshold. So if there's just one error, that doesn't exceed the threshold and we don't get any ECS report.
I thought you would be able to see that that row had an error, but I don't know. I think maybe it depends on how you set it. Yeah, can one of the memory folks speak to it?
I think it's configurable via the mode registers, what that
Yes.
threshold is.
Mita, you're correct. Yeah, but my understanding is that the threshold there's a limit to how low we can set the threshold in those mode registers, and I think it would be good for our DRAM vendors to weigh in on actually how that's implemented.
Yeah, I think
Oh.
they're JEDEC defined,
Yeah.
Charles.
Yeah,
I could just go look at what they are. I don't remember exactly what options we have,
yeah,
but the
Sure.
minimum option is still not a very low count.
yeah,
Okay.
right.
Oh,
Yeah, so
I think the minimum is
we should
4.
Yeah, and I think it's for, yeah, the definitions are complex because they're based on number of rows failings, number of cache lines failing. So there are different ways you can count it, but if we want to get more details in here, we can.
yeah, because I thought
yeah, maybe
it said the row that had the most errors that would always log that, but maybe I misunderstood it. So can I give you an action item, Evan, to?
Yep. Yeah, it's still the row with the most errors, but it still has to exceed some threshold. But I'd have to go look at what kind of the minimum is there.
Yeah, all zeros is 4.
Oh, thank you. Okay, so maybe that you've already looked, Sean. Was that Sean speaking?
Yeah, the MR15 ECS
Okay,
error threshold, the lowest you can get it set to, it is 4. If you set it the op all 0.
so okay, so since the lowest CS or actually CS hides is threshold or lower than a and the threshold not be set lower than 4, this error is invisible to us. Okay. So it's still invisible. Okay. Okay, so then let's say software writes a 1 to a second bit in the same cache line. And I need to clarify this in the same cache line that previously had a line. Okay, and if software's not actively using the cache line, then only the patrol scrubber sees the error. And I guess I should, but and it might be a 2 or 3 bit error, 3 from a miscorrection on the in the DRAM using internal ECC. So you might miscorrect that double bit error, but chip kill will still correct it. And so the visibility at that point, polling software will see that error. Leaky bucket will probably not see the error because the rate is too low. My memory is broken. And then I'm going to accept your change. both hardware and software rate limiting will interrupt and log the error. Okay, and now the memory errors will be placed in RAS API queues delivered to analysis tools. It doesn't matter if it's in band or out of band. Assuming a C% to an analyzer, analyzer will know that only cache the only one cache line address is failing. So even though we know that we have a partial row failure, all we see is one. One failure address. And so we don't have enough information to assume anything other than a single bad cache line address. So, there's not much data here. So let's say that we, software then starts reading the failed partial row, but infrequently. So now we'll start seeing it. Both Patrol Scrubber and demand reads will log memory errors. So the polling software will see the error. Leaky bucket probably will not see the error. So we have a failure, and we've thrown away the early warning as a result of using leaky bucket. So we blinded ourselves by using it, and it's not great. And then both, thank you, both hardware and software rate limiting interrupt and log the error. Now, if a CPER is sent to the analyzer, the analyzer will know that only one cache line address is failing, and with an error at only one memory address, we don't have enough information to assume anything. We might suggest mapping a bad page out at this point because we've seen repeated errors. We might try a soft PPR for this, but that's like a pretty small error to do a PPR. So let's assume that we don't, and that way we'll watch the scenario progress. So software begins to read that failed row frequently. So now we're having more and more. We're going to see a bunch of errors, and yeah, I hear you, Mita. I'll say, assuming page. Okay, let me unfold that. Thanks, Mita. That's a good comment. Okay. So we still only have a couple bits that will be detected. Just the two ones we wrote earlier. And now we might have a potential storm because it's frequently accessed. And so demand scrubs impact performance, interrupts can impact performance. But nothing changed. The only thing except that the software started reading it more often. And so that's one of the things I wanted to show people is that I had the same failure the whole scenario. And at one point I barely saw it or didn't see it at all. And now I have an error storm. And the only thing that changed was software started reading the data. So, kind of the point is we're along for the ride when it comes to memory errors. We're subject to whatever software it happens to be doing on the system. And so, the visibility, I think maybe everyone sees it, even the leaky bucket. We'll see it now. Certainly polling and rate limiting, but the rate limiting is nice because now it's just interrupting periodically, whatever rate limit we've set. And it's the nice leaky bucket will trigger every time the software crosses the threshold. So it's slowing down the interrupts, but not necessarily at a predictable rate, because you could still cross the leaky bucket threshold pretty quickly if you have a really constant error storm. And so the beauty of rate limiting is that it's very periodic. You say, I got an interrupt for a memory error, don't give me any more interrupts for a time interval. And so it's very regular and predictable. And so it's easier to do scheduling around it. And it's also easier to collect the data because you have a max data rate through your pipeline. You say, oh, at most I can get one corrected memory error, let's say once a second, and a corrected memory error is 2 kilobytes in size. So therefore, my data rate is 2 kilobytes a second. and you can reason about the max data rate and use queuing theory to design an infrastructure that supports that. Where with Leaky Bucket, you can't do that. You don't know the upper limit to the rate at which you're getting interrupts. So now, assuming the CPER is sent to the analyzer only know that one cache line address is failing, and software that counts memory errors might assume the DIM is failed. But at this point, we really have only one address that's failed. We could map the page out and not need a service event. But counting is bad here. Counting isn't really telling you what's going on. Now let's say that software writes ones to another cache line in the failed partial row that's used frequently by software. And I think, yeah, because I did break out the, I need to break out the error storm separately from the second one being written. I can do that. But in this case, now we've written another cache line. We still have the potential error storm. Demand scrubs can impact performance. Interrupts can impact performance. But we've got a more widespread failure, but the underlying fault did not change. We just changed what the software was doing in memory. And all the methods of logging see the error. Now the analyzer can look at the series of errors and say, gosh, they occur along the same row address. So the analyzer now can infer the fault from the error because it sees a pattern across multiple addresses. And so it's clearly a row failure. So now it says, oh, I can do a post-package repair. And the analyzer can also look at the ECC's ability to handle the inferred row failure and say, okay, I know I've got chip kill. The machine's not going to crash. We can generate a CPAD that will indicate a PPR will be done, including all the needed parameters, such as the row that needs to be repaired. We send the CPAD to the cloud service provider, or I'll say server fleet operator since we've converged on that. And then we decide to send the CPAD back to the machine, or we might, if we don't believe the analyzer, decide to replace the DIM. But let's say we take the self-repair action. The RAS API can send that back. CPAD gets the machine. The machine acknowledges that it got the CPAD. The CPAD can be acted upon immediately if we support runtime PPR, or it may be delayed until the next boot. When the RAS API gets around to acting on the CPAD, it will create an informational CPER. That informational CPER will indicate whether or not the repair succeeded or failed. And then it will just send that error log up the same path that all the other memory error logs go. So now the analyzer will see that the RAS action has been taken. And so let's imagine that the informational CPER says, hey, we have memory errors. I tried to do a PPR failed. Well, the analyzer will see a whole bunch of memory errors. It'll see that we tried to do a PPR and it failed. And so now the analyzer can say, well, it can maybe send a message saying, try to map out pages. And if the map out pages fail, it can say, it's time to replace this DIM. And so that's the overall scenario I was trying to walk through. And I'm trying to illustrate that we want to see the early errors and that we're along for the ride, that we're subject to whatever software is doing on the machine as people that are doing runtime monitoring. So that's the scenario. That went pretty quick. Either it made perfect sense, and there are no questions, or I'm boring you, or something in between. I don't know. Like what do you all think? Is this useful?
I think it's
It's really
incredibly
good stuff,
useful
Dim.
to have it, Drew. Yeah.
Okay.
I think it puts words and kind of a flow to things we've been talking about a lot the last couple of years.
Well, and Evan, my dream is that we publish something like this, and then when you talk to your customers, and your customers like, hey, I had 100 memory errors in a minute. I'm going to replace your part. You can share a document that has all of our names on it and say,
Yeah.
it's not just, Micron claiming this. We have an industry consortium with all the memory vendors and hyperscalers, and we've written this, and don't do what you're doing, and here's why it doesn't work. And that way you're not telling, you don't have to tell the customer they're doing something wrong. You can just say, look, here's a good industry document you can read that explains how this works.
Yep. Yeah, I had this come up in a meeting just last week. I think this would be really helpful.
Okay, feel free to share a draft of it. I mean,
Yeah, I actually, during this meeting, I sent it out to a whole bunch of my team and asked for help kind of refining it. And I think this will be really useful for us.
Okay, cool. And like I said, I guess, my dream is that we document things like this so that we can get more and more people on the same page about best practices here. And then as we build out the RAS API, we build out the fault management infrastructure we're building, we build out the FM analyzers, we have some supporting documentation that says, look, we understand the subtleties here. Here are some of the subtleties. If you want to use a solution that addresses all of this, come adopt our solution. We've got something that will help you. Cool. Okay. Well, we're about out of time, but I welcome feedback. So, if you like, Amita, thank you so much for your comments, and others. What I'd like to do eventually is publish this. I don't know if it's a contribution or, we need to think about how we do that, Yogesh.
Yeah, Drew, I was thinking about this. I think, yeah, we can definitely contribute it, but I think I want to do more than that. I think we should probably do a tutorial on this and record it.
Yes.
But that basically requires, I mean, I need to put in more work, put some diagrams in here, and then we can work on that, and whoever else wants to join the effort it'll need a lot of help, but I think that would be the best.
Oh, absolutely. And like, this was tersely written, just to go through the concept, and so elaborating it with pictures of like what's going on inside the DRAM. There's so much more that could be done to make this clearer. Absolutely.
Elaborating with pictures, and if it could be a tutorial, and if frequently asked questions or something, recorded, something like that. We'll have to figure out, but I think yeah, we need to give it more time.
Yeah.
But it's really good. Thank you so much for continue to work on this. This is really good.
Awesome. Well, and my deep hope is that the folks from SK Hynix, Micron, and Samsung will help me write this and put their names to it too. And that way we can say, look, the hyperscalers and memory vendors have worked together on this, and we are jointly giving you best practices.
So we have two more ingredients in the solution. One is your operating system, and other is your whatever your silicon CPU vendor does, right? The BIOS system software.
Those two, absolutely, yeah.
Right.
And
so we need to get those angles in there too, because right now we are talking of idealism of it, but then there are scenarios which people handle them differently, may add value, may just muddy the water too much. We have to figure that out.
Well, and the other thing that we can do is, I tried to do a scenario that went through corrected errors, but we can talk about how, the uncorrected errors were, like, we have other scenarios too that are part of the overall tutorial that give people a more complete picture, because it's kind of hard to give someone a complete picture with just one scenario. But I hope that you all will join me in building some educational resources here for folks so that we can get more people on the same page.
Yep. Okay, on a minute over here, Drew, look for my text. I think I need to some side huddle. Okay, thank you, everyone.
Yeah.
See you all next time.
Yeah, thanks everybody.
Thanks so much.
Thanks.
And
Bye.
please put your comments in. You know, I value Mita. You're awesome. I really appreciate it, but I would welcome others.
Yep.
Yeah,
Thank you,
thanks, Drew.
Thank you.
Will do.
Okay.
Thanks.
Okay.
Bye.
Talk to you later.